Hello and welcome back to ADIPEC Energy Dialogues, a series of conversations we're bringing you in the run-up to ADIPEC 2020 taking place this November. ADIPEC Energy Dialogues are a series of conversations we're holding with industry analysts and experts from across the sector and to discuss, in this case, the implications of digital innovation on the fortunes of the industry. And today, I'm absolutely delighted to be joined by Steve Lewis, who is the Managing Director of Eternal Energy. Steve, welcome to Energy Dialogues.
Thank you for having me.
Today's discussion will focus on the offshore because, Steve, that's an area of focus for you. And the offshore is an incredibly important part of the overall oil and gas industry. So let's begin with the current state of digital readiness in the offshore. I mean, it's a complex, interrelated series of players, services, and technologies. And so digital readiness obviously is going to be a bit more of a challenge here. But how would you characterize the state of readiness today?
Sure. Well, are we ready? I will look back. If we look back 20 years ago, for instance, investment in technology was very expensive. Data outside of your cubicle was difficult to access. Obtaining information while offshore was nearly impossible. We had limited connectivity, maybe a single sat phone and limited two-way radio. So mainstream digital adoption had yet to occur, so we were not ready back then. But today, investment is relatively cheap in technology. Take, for instance, the cost of a gigabyte of storage. Back in 1981, it was about $500,000. Now it's less than 3 cents per gigabyte. The information is now abundant. Data is accessible thanks to cloud computing. Connectivity and data transfer speeds are very high. So today we are ready, but more than that, we are very willing. Where the majority of us have lived in an analog world and now have transitioned to a digital one, the new wave of graduates coming on have never not known a world without the internet. So it's not surprising to see some organizations get ready for that by having a chief digital officer, for instance. ABS and Weatherford have those. McDermott has a manager of digital culture and transformation. And this is huge because they found that culture was the most significant barrier to achieving digital objectives. So they implement these KPIs that address upskilling and awareness and engagement of the workforce. They have programs that teach employees about digitalization and innovation. And they're not alone. So the offshore industry is ready and willing to embrace things like cloud computing, digital twins, AUV, AI, VR, blockchain, and one of my personal favorites is 3D printing.
Let's turn to the specific elements of the offshore and consider how those features of their business model show such promise for adoption. And why don't we start with exploration, because that's where the process starts. How do you foresee or anticipate exploration addressing digital opportunities?
There's a lot of opportunities there, and the way my firm has identified those, it was actually, we got one of those insights from your book actually. It was that fact that digitalization occurs when you combine data with analytics and connectivity. So we know where the highest potential is based on which part of those three have all three elements. So example of exploration, we conduct seismic surveys that generates terabytes of data. And then we perform a reservoir characterization model and analysis. And then we send it back to allow for optimization to occur, optimization of the production to occur in real time. Then if you move over to the concept of the pre-feed and feed, again, we do geophysical surveys with lots of data. We're able to analyze the optimum well placement, and then we share that data with all the stakeholders to develop the entire field architecture. We look at another thing, we tend to think of offshore as only what happens over water, but in fact, we move hundreds of billions of dollars of material each year all over around the world. So material management can benefit from digitalization by tracking and tracing and having a real-time record of those items. simply by using some inexpensive RFID tags. And then there are opportunities down the chain with construction and operations. One good example is by extracting data in real time from the motions of the floating platforms and marine vessels, we can calculate the actual remaining life in those moorings or riser systems. And we can then use predictive analytics to take rotating equipment, for instance, estimate rotating equipment that when it actually requires maintenance and plan for that, rather than having unnecessary routine maintenance, stoppages, or unplanned failures. So in other words, it's less downtime and we extend the life of the field. And that's important because the final step is decommissioning. That is very expensive. In fact, WoodMac has estimated that in 2030, there will be over $100 billion worth of abandonment liabilities worldwide. So using data analytics, you can extend the useful life of the asset and better manage those expenses.
130 billion is a very, very large number, and really calls out for innovation and more innovative thinking around how to move that cost into a significantly better position. Just in the world of decommissioning, thinking about that, not all basins around the world are in decommissioning state, say to the same degree. Can you provide some examples of where digital innovation in decommissioning could make a big effect on the economics of decommissioning activities?
One of the real easy things I would say, it's some low-hanging fruit, if you will, is just by having a digital twin of that subsea structure, we're now able to go in and identify how to remove it piece by piece, for instance. The drawings that we have from those production facilities that were created in the 70s, 80s, we may not have up-to-date drawings on. So now we have a full, very accurate model. And one of the things that we found is that marine growth has added an extra weight to that platform, which would have us change our lift plan. There's technology out there from a company called Diesel that is working on a solution to identify the actual marine growth and know exactly which type it is and how much to calculate the weight based on that density. So yeah, a lot of opportunities in that area.
If offsetting or doing the calculation can enable the lift to be done one time correctly with the right equipment, it can be a big cost saving because you don't have to mobilize a different crew and a different rig set to be able to carry out that removal.
Exactly.
What blocks the offshore from advancing and adopting digital innovations? Is it it's obviously the sheer mobilization challenge is very plain, but what else blocks innovation adoption?
There are a lot of factors, and some are in our control and others aren't. I'll highlight a couple major ones. One is oil price volatility. It affects technology development, maybe not in the way that some might think. So clearly in a downturn like we're in now, oil prices are low and we instinctively cut budgets that are not considered essential. And sure, R&D is one of the first to get that, to face the chopping block. But on the flip side, during high oil and gas pricing cycles, we simply don't have the time or resources to invest in R&D because we're following this very proven model of engineer it, build it, install it, operate, and repeat. So when is the right time? One could argue that there never is one. But clearly those organizations that do innovate achieve higher levels of return in a long run scenario. The other thing I'll point out is that us offshore personnel are conditioned to minimize risk because the consequences of an incident are so high. But one of the unintended consequences of that is that we created almost zero tolerance for mistakes. Now, in technology development, we test out multiple scenarios. Many of them fail, and that's okay. We're in a discovery phase. But when we hear announcements of mass layoffs, and are we really going to take the chance on potentially wasting resources or even failing? So the organizations who say, to their people, it's okay to make a mistake, it's okay to try something new and fail. Those have created a culture of innovation, which we talked about, and ultimately they will be more competitive, they'll have higher morale, and thus be more productive.
Yeah, certainly culture is one of the, my sense is one of the most significant barriers for the industry to overcome in addressing digital change, which happens so quickly and in much more of a trial and error way than what oil and gas works towards, which is no errors and no mistakes, highly safe with high integrity and reliability. At times it feels like these two objectives are in conflict. And yet, there are those who are finding ways to overcome those challenges. I wonder if you have any examples to share where some offshore players have created ways of addressing this dichotomy of speed differential between these two sectors.
One of the things that I really like, I'll go back to the McDermott example, is they have an idea sharing platform. I think it's called Innovation Exchange. This is where any employee can put their idea out there. Let's say it's automating a material takeoff for faster, more accurate MTOs. Well, they know exactly how to apply and submit that idea. They know how it's going to be assessed. They know it's how it is going to go through the process. And so they are, not only that, they're part of that process. So understanding how the process works and then what the outcome, and being a part of that whole process itself, is one of the ways that companies can make sure that they're able to overcome some of those challenges.
Yeah, and that your example actually touches directly onto this whole question of culture by creating a culture of openness where employees feel free to surface their ideas and their insights with the idea, or at least the understanding that those ideas will be taken seriously, is an important critical cultural dimension for organizations to take on board. Now, in terms of the offshore industry and its history, many of the offshore facilities were built many years ago, where they predate the digital era. And so as a result, they may not have adequate conduit or the networking capabilities, or even in some instances, the power infrastructure necessary. How does an older offshore platform participate in a future digital world? And related to that, what is the future of these platforms as we adopt more and more of this technology into the industry?
Sure. Many of the platforms that came online well before the turn of the century are still in production today. And they've been designed and built to withstand that test of time. We know that operators are submitting a record number of life of field extension requests to their regulatory bodies to keep these platforms working past their initial design life. And digitalization has a big part of that. Each of these platforms, as you can imagine, consists of a complex network of piping, and plus all different sized and types of flanges and valves and hoses, pumps, generators, tanks. So every day, offshore personnel will test, inspect, and maintain and repair all of these systems. Now, a couple of ways in which we're seeing these older platforms take advantage of digital innovation is through that inspection and maintenance process. So instead of utilizing paper-based work permits and procedures, we're moving to digital versions. So it ensures that all the relevant personnel, both on the platform and offshore and onshore, are aware of what's taking place. One startup called Andium, based in Boston, they use telemetry to remotely visualize fluid levels inside steel tanks, which is kind of important if your crew needs to open it and inspect or clean it. There's another startup called Digitex, which can create a perfectly accurate P&ID and convert that, the entire top side, into a digital twin, and then map out and track the entire inspection plan quickly and accurately.
So these, what it highlights is that these assets by no means should be viewed as truly forgotten and frozen in time. There are ways to actually advance these assets into a digital era.
Yeah. Still a lot of value left in those.
Yep. Now, what does it take to accelerate digital adoption? You've mentioned ideas exchanges as one possibility. The pandemic here has clearly shown that the industry can embrace change very, very rapidly as we went from a largely office-based workforce. Not in the operational areas, but in the office world of oil and gas, commercial world certainly, to a home-based workforce almost overnight. So change can happen very quickly when it's necessary. But what are the other sorts of things are out there that can help accelerate a change? Is it do oil and gas concerns need to reorganize? Do they need to look elsewhere for innovation? What's your sense there?
To accelerate change. In a previous role, I reported to a brilliant leader. His name was Chris Tam. And when he was ever tasked with a challenge, he would tackle it by a framework, using a framework called, where he said people, processes, and tool. And he always spoke in those terms and with the order of those three things being important. So we always spoke about creating a culture of innovation. That's the people aspect of it. We touched a little bit about the process. How was the technology implemented? What worked and what didn't? Was there even a process? And if there was, in a lot of cases, we asked the question, well, what stage did it break down in? So yeah, we mentioned the McDermott example of innovation exchange. I'll say a couple other important aspects to keep in mind, and this might cover a lot of different industries, but particularly for offshore, is to make sure the innovation is as easy as possible to integrate into your organizations or your client's organization, existing systems. I had a client that had a very powerful GIS platform as part of their overall offering. But we learned from the end user that their decision-making process wasn't actually based on cost. It was based on the ease of integration and being able to keep their own system in place. And that information helped us gain adoption faster, and it helped us revise our pricing strategy. It was important. The commercial model is also something that when I work with a lot of clients that are startups, they need a lot of help in. We sometimes want to, with all of the investment that we make in R&D, we want that first purchase order to recoup all those costs. And that simply isn't realistic. So we put together pricing strategies and commercial plans to help that startup get through the organization, let them do a pilot and a trial with the end user, and then have established that relationship with a proven model moving forward.
So it's not as black and white as it feels, which is I have a clever technology. There's a specific use case in the offshore, and it's embraced. The commercial issues often also have to be taken into consideration in order for that technology to receive any attention. And your point about the impact that change will have on the overall offshore business model is not lost. The minimizing change and that impact actually is also a significant concern. Let's turn to the automation question, because the use of robotic tools now is starting to penetrate industry after industry after industry, and the offshore industry, no less than others, has been an early adopter of automation tools, particularly underwater robots and remote operated vehicles, or ROVs as we call them in the industry, to carry out inspection work and subsea maintenance work and so forth. These tools have advanced very, very quickly and very rapidly. How do you see the trajectory of these tools in the offshore? Are they going to continue to be embraced and expanding in their capability?
Yes, the offshore industry has certainly come a long way in this department. Early ROVs, they had a limitation. Let's say, we can say poor visibility, lots of downtime, and restricted excursion distance when you're due to the tether that goes back to the vessel or the rig. So let's talk about those three advancements in particular, because digital technology has advanced all three of them: visualization, downtime, and distance. So I mentioned this company out of Portugal called Abyssal. They take existing ROV video from a survey, for instance, and digitize it and catalog that. They can then analyze it, visualize it, and transmit it. So now an ROV pilot can view an augmented reality overlay with enhanced visibility and with contextualized data on the screen. So we're talking warning labels or measurements or even fly routes, to name a few. But the enhanced vision portion is very important. I was on a project, an offshore project, where it involved recovering an asset from the seabed. And because the ROV had to come so close to the ground, the thrusters were disturbing the soil.
Of course.
And caused zero visibility. And so we had to stop. We had to wait for the debris to settle, which made the operation take days instead of minutes. And because during the wait times, the ROVs had to go back to the surface for repairs. So if we had had that digital application, we could have had it with zero downtime and done that operation quickly. Digitalization also allows for ROVs to be controlled remotely from onshore, but also it allows for the ROV to be, you mentioned, fully autonomous. And so it's making decisions, it's avoiding collisions, it's free from the tether, so it can go anywhere it needs, and as long as it has the battery life. So talking about battery life, Saipem has a underwater intervention drone, is what it's called, and it's called the Hydrone. And it is subsea resident. That means that this vehicle is housed in a subsea garage on the seabed that's permanently integrated with the subsea production system, and it can receive power and communication that way. So it never has to be recovered to the seabed except for maintenance.
That's an example of that I've seen in the aeronautic world, where on pipeline infrastructure, a drone may be resident in its own housing and almost like a capsule, where when it's required, it will fly the route to inspect the assets from the air. That same innovation now coming to the subsea. That's very, very impressive. What benefits does this yield to the offshore operator? So one example, I think you mentioned this, was that since the ROV doesn't have to be operated from directly on the platform, this will relieve congestion on the platform, trips of specialized operators, a reduction of training costs for individuals who are, say, unfamiliar with an offshore world. These are the sorts of benefits we're talking about from this kind of technology solution.
Absolutely. They're the subject matter experts in our industry. They're retiring. We call it the brain drain. Well, they don't have to go offshore for every trip. Currently, right now, they don't have to be quarantined for 14 days before and after. So they can do their job from shore and not have and bring that experience to the team no matter where they are.
And how far from the fully autonomous offshore rig do you think we might be? It still feels like it's off in the distance, but how far off are we talking now? Decade or longer?
You know, Jeffrey, we're actually there. Equinor had just launched their world's first fully automated oil and gas platform called Osberg H in the North Sea. It is totally unmanned, except for maintenance visits. There are no living quarters, no helicopter deck, no lifeboats, no galley for food, and so the benefits are immense. For one, it's now lighter in weight because you don't have those structures, and so it's cheaper to build and faster to install. And in fact, I believe it came out to be about 20% lower than the cost estimate, which that's impressive for any industry. The break-even price went from $34 US dollar down to about under $20 per barrel, if I recall. So it could be those types of innovations can allow for very profitable developments. Other costs.
Unlock other fields too, I would imagine, fields that might otherwise have been hard to capture.
Exactly. We over here in the Gulf of Mexico, we talk in terms of long distance tieback, so in excess of 30 to 50 miles in some cases. So there's other cost and weight savings that can be accomplished, especially for those types of developments where we use a all-electric subsea factory, whether it's power, processing, separation, boosting, chemical injection is a big one. That can all be moved from the top side down subsea close to the wells, and then remotely or even automatically controlled.
We've mentioned earlier in this discussion how safety is critically important to the industry. I'm pretty confident that digital innovations are also now affecting the safety profile of the sector. In part, as we move to autonomous tools and robots carrying out work, we remove humans from harm's way. So that's obviously has a positive safety effect. But in other cases, jobs are not so easily changed or displaced with robotics. How is the world of safety in the offshore, therefore, being affected by digital innovation?
Well, this is our number one priority in the offshore industry, is safety. And we all adhere to a hierarchy of controls framework, which is ordered in terms of effectiveness. The number one thing we do is to eliminate the risk. So as you mentioned, we talked about the unmanned platforms, just removing the humans from the equation. Then we look at the next most effective thing is substitution. And then down to our controls, which we have a lot of engineering and admin controls, whether it's audits, JSAs, observation cards, nonconformances. And then the very least effective is the PPE, like the mask, the hard hats, the safety glasses. So even despite those things, incidents do occur. According to a 2012 study, 88% of all water-related incidents were due to human error. And the biggest reason is either miscommunication or lack of communication. Effectively, it's not knowing or understanding the risk. So one of the technologies that's getting a lot of traction, and one of our clients, they have augmented and virtual reality training simulations. We refer to this as immersive learning. So instead of having a new recruit put on the platform and say, here's a manual, just go figure it out, we're now able to say, place that individual in a simulated environment and perform these complex tasks virtually. Sometimes with instruction, sometimes without. It provides repetition learning, instant feedback. They can make mistakes, and that's okay in that environment. It's a constant reinforcement of those skills, and we can provide variations of that simulation to make sure that we account for all different types of.
Very much the same way that the aerospace industry trains pilots in simulators, and similar concept.
Exactly, and studies have found that this helps people remember better and understand better, and that has a direct correlation to lower incident rates and improved productivity.
Right. Now, the last problem, of course, I'd like to address today deals with the pandemic. The pandemic obviously is driving a dramatic change into society. And while we're not sure if it's temporal, we will quickly revert back to where we were. Since we don't know when the pandemic will end itself through a vaccine or immunities, the industry is having to address the pandemic now as it currently runs. How is the pandemic impacting the offshore industry?
That's certainly been top of mind for 2020. And I think we'd all agree that the pandemic has accelerated our adoption of remote communications, remote operations. So we effectively reduce human exposure. So I guess that we can say that's one small positive we can get out of this horrible virus. Not just looking at the difficulty in sending people to different countries, because we cover the globe offshore. I'll mention that the subsequent oil price collapse due to the pandemic had forced several offshore FIDs to be postponed. This is financial investment decisions. They're either postponed or even canceled. So then all of the workforce that was going to address that, they're being cut. And we saw something about, I think the number was 100,000 layoffs that happened this year in oil and gas. But we anticipate that offshore will rebound. And that will require a lot of those experts back who have maybe gone into different industries, like aerospace, for instance, and aren't coming back. So there are startups like Oil Energy Pro who are developing an online platform specifically for offshore oil and gas professionals that will connect them to hiring organizations and hiring managers directly to prepare for that recovery period. Again, that's the people aspect of it.
That'll be the part of the challenge that likely will be in short supply is that level of expertise.
Absolutely. If I can give you one prediction I'll make, is that for the offshore energy sector, all assets coming online starting in 2022, so about a year and a half, will have a digital twin associated with it. And when you can simulate anything with that digital twin, the possibilities are really endless. And talk about improving safety, talk about increasing operational efficiencies or improving communication. It's all up to the people that are to do this. I mean, after all, technology is a tool. It's really the people who give it a purpose.
And well said, well spoken. Steve, thank you very much for joining us today on Energy Dialogues.
It was my pleasure. Thank you.
I thank you as well for taking in this brief conversation today, and I hope you'll return for future episodes in the run-up to ADIPEC 2020. Bye for now.